All right, growth and decay is what we're going to be looking at today. However, before we start on that growth and decay, just a quick reminder on what we did on Friday. Friday we were looking at exponentials, and those exponentials were in the form y equals a times b to the x power. This is what we saw on Friday. We noticed a couple of things about a and b. First, let's talk about a. On Friday, we said a couple of things about a. What did we say about a? What did we notice about a? Where did it show up in our table? I know. Where did it show up in our table? A was always right next to what number in the table? Zero. Yeah, it was always right next to 0. As a matter of fact, we call it our starting point or our initial value. That's what A is. It's the initial value. It's what we start with. It's always right next to the 0. We also talked about B. What does the B represent? What did it do? All right, Brett, what did B do? B. B represented what? The pattern, or what we were multiplying by, or the ratio. We use a couple of different words here, okay? Those of you that weren't here on Friday, make sure you're keeping up with this because it's going to show up again. All right, so again, B was the pattern. It's what we were multiplying by, or it was the ratio. As a matter of fact, we notice in our table that the y values, sometimes those y values got bigger, sometimes the y values got smaller. So, yeah, y values got bigger whenever the b was what kind of a number? This is on Friday. The y values in the table got bigger if b, this number right here, is what? What kind of number? Well, that's part right. You're right. It has to be a positive number. But you got to be more specific than that. Greater than, nope. It's going to be greater than something, but it's not 0. Nope.
What?
1. Greater than 1. If b is a number greater than 1, the y values increase. If that b value is between 0 and 1, then the y values are going to decrease. This is what we saw on Friday. Now, it's real helpful if you remember all of that, because then it makes the day very easy. But if you don't remember it, well, then it makes things more difficult today. So it sounds like we're going to have a difficult day today. All right, so here we go. Like I said, on Friday, we were looking at the equation in the form y equals a times b to the x power. Today, what we're going to do is look at an equation a little fancier than that. And that's this one right here. Y of t is equal to a sub naught, or a sub 0, times 1 plus and minus r to the t power. Now, although that looks very confusing and very difficult, it's actually very, very similar to what we saw on Friday. Very similar to this right here. Now, notice how this a with the little 0 right here represents our original amount. Well, that's the same thing it represented for us on Friday, the initial amount. It's the number that we're going to see right next to 0. So it's the same thing. R. R is going to represent the annual percentage rate. Annual percentage rate of increase, which we're going to do some addition for increase, or decrease. That's when we're going to do the subtraction. T is going to represent our time in years. And y of t is going to represent the amount after t years. Now again, I know it looks confusing, but it's going to be very similar to what we saw on Friday. So let's take a look at a couple of examples here. The first one, right now, the population of our town is around 25,000 people. However, the number of citizens is projected to increase by about 8% every year. So what we want to know is, what would the population be in the town after 4 years? That's what we're looking for. All right, so let's see here. We know the initial amount. We know what we're starting with. We know we're starting with 25,000 people. So let me start there. That right there is our A, or A sub naught in this particular equation. Matter of fact, we just got through saying that we're going to find that number sitting right next to 0. So 25,000 is what we see in our table right next to 0. The tricky part is figuring out what number goes right here. And we're going to find that number using what we know about the equation. So right here it says we're either going to do 1 plus the rate or 1 minus the rate. 1 plus or 1 minus. So let's think about this. Let's think. It says here that the population is projected to increase. Increase. So, Lorenzo, if the population is going to increase, are those y values going to get bigger or are they going to get smaller? They're going to get bigger. So, if these numbers over here are going to get bigger, our y values, what does that tell us about the number we're looking for over here? We just talked about it a second ago. What do we know about this one? If our y values are going to increase, this number that I'm looking for has to be what kind of number? Daniel, what did you tell us earlier about that b?
Greater than 1.
Greater than 1. The number we're looking for has to be a number greater than 1. So, how are we going to find that number? Well, we're looking right up here, guys. What we're going to do is we're going to take 1, and we're going to add to that 1 our rate. And our rate right now is 8%. But I want to change that percent to a decimal. Anybody know what 8% is as a decimal? 0.08. 0.08. So, to find this missing number, the one that goes inside the parentheses there, we're going to add 1 plus 0.08. What do you get when you add 1 plus 0.08? 1.08. There it is. There's our equation. Let's go to the calculator, go to y equals, and type that equation in for me so that we can finish filling out our table. Go to y equals, type in the equation. Now remember, you're not going to use t, you're going to use x in your calculator. So it's 25,000 times 1.08 to the x power. All right, Gilbert, you're going to help me out help me fill out this table. Right next to 0, I know you see a 25,000 because that's the initial amount. What about the next to 1? What do you see next to 1?
27.
Good, 27,000. Next to 2, you see what, Gilbert?
29.
29,000. 16, you sure, or 160?
It's 29.16.
Okay, make sure you typed it in correct. I think you might have your decimal in the wrong place, so double check it. 29,106 is what we should have. What about the next one? 31,193. And the last one should be 34,000 and what? This is what the table should look like on your calculator. So what is it that we just found out? We just found out that the population of this town, after 4 years, is going to reach 34,012 people. That's assuming that it increases at 8% every year. If it does that, the population should reach 34,012. All right, let's take a look at the next one, number 2. Number 2 says that Mr. McDonald just bought a farm tractor for $60,000. For tax purposes, its value is expected to depreciate at a rate of 18% annually. What will the tractor's value be after 4 years? I want to know, what is the tractor worth after 4 years if this holds true? All right, so let's see if we can come up with an equation. Remember, I'm trying to come up with an equation. It looks similar to that. A sub naught, the original amount. Do we know the original amount of the tractor? What is it worth? 60,000. That's what he bought it for. 60,000. That's what we're going to see right next to 0. 60,000. Now here's a word we don't see very often. This word, depreciate. What the heck does depreciate mean? It goes down. It decreases. All right. So what's happening is the value of that tractor is going down. Is that what really happens in the real world? When you buy a new car, what happens as soon as you drive it out? It goes down. It depreciates. Okay. Same thing for this tractor here. Now they tell us it depreciates at a rate of 18% annually. All right. So These y values, if it's depreciating, are these y values going to be getting smaller, or are they going to be getting bigger? Smaller. So if they're going to be getting smaller, that tells us what about this number over here? What kind of number are we looking for? No, not negative. Less than 1. Something between 0 and 1. That's what we're looking for there. So how are we going to find this number that's between 0 and 1? Well, again, look up here. Right over here. Because we're talking depreciation, what we're going to do this time is we're going to do 1 minus. 1 minus. 1 minus what though? There it is, 0.18. That's 18% as a decimal. So what would we get if we subtract 1 minus the rate? 1 minus 0.18. 0.82. Notice how that's a number between 0 and 1, which should give us y values that decrease. All right, Lorenzo, put that in your calculator and help me fill out my table here. Go to y equals 60,000 times 0.82 to the x power.
Times 0.82.
Times 0.82 to the x power. All right, we already got the first one, 60,000. What's the next one, Lorenzo? In your table. You got 60,000. Got it?
Next one is 49,000.
Okay, 49,200. Okay, the next one? 40,344.
33,082.
Good. And the last one?
27,100.
There it is, 27,127. All right, so notice here, after 4 years of owning this tractor, how much is that tractor going to be worth after 4 years? $27,127. So it's lost a lot of its value, guys. It used to be worth $60,000. Now it's only worth $27,127. Okay. Now, with that equation still in your calculator, I want you to go down a little further for me, and I want you to find what would the value of the tractor be after 10 years. Look in your table. What's the value of the tractor after 10 years? 8,246. Very good. 8,246. What about after 15 years? What's the tractor worth after 15 years? Okay, so notice how the number is getting smaller, right? What I want you to do is I want you to keep going down your table. Now, I don't want you to say anything out loud. I just want you to find this next one for me. I want you to find how many years is it going to take for the tractor to be worth 0. Get your calculator. Get your table. I want you to see if you can find where is it or how many years is it going to take for the tractor to be worth 0. Don't say it out loud. I want to see if the rest of us can find it. How many years does it take for the tractor to be worth 0? Nothing. When is the tractor worth nothing? Anybody found it yet? What are we on so far? 90? And it still hasn't reached 0 though?
Well, after that, it looks like it's like 8 point something.
All right, guys. The tractor, I asked you, when is this tractor going to be worth 0? That was a trick question. Truth is, the tractor is never going to be worth 0. I don't care how far you go down, the tractor will never reach a value of 0. Never, never, never. The tractor is always worth something. May not be worth much, but it is worth something. So that was a trick question. Wait a minute. This all sounds familiar. We got closer and closer to 0, but we never actually got to 0, right? What do you call that? We've seen that before. When you get closer and closer to something, but you never actually quite get there. Started with an A, you remember that? Asymptote. You remember about asymptotes? That was when we got closer and closer to that line, but we never actually got there. That's the same idea here. We're getting closer and closer to a value of 0, but do we ever actually get to that 0? No. That's that asymptote. Okay? All right, let's go to number 3. Number 3 here says that a manufacturing plant sends 50,000 cubic feet of CO2 into the atmosphere annually, but it has signed an environmental agreement to cut these emissions by 12% each year. To what level will the carbon emissions drop in 4 years? All right, so let's see here. We know the manufacturing plant sends 50,000 cubic feet of CO2 every year. That's the starting point. That's the initial amount. So let's put that right here, 50,000. Matter of fact, we're going to see that 50,000 right next to 0. What we need to do is find this missing number over here. Now let's go back to the question. It says here that they signed an environmental agreement to cut the emissions by 12%. They're going to cut the emissions. So, are my Y guys going to get bigger or smaller than 50,000? Smaller, because we're cutting. So, we need to figure out what number goes right over here. So, let's see if we can find that number. We're going to do it very similar to one of the others that we did. We're looking at that equation again. We're going to do 1 plus or minus? Minus. Minus because we're cutting. Minus what? What was the rate? 0.12. That's 12% as a decimal. So let's see, what do we get? What's 1 minus 0.12? 0.88. That's what we're going to use right here, 0.88. All right, now that you have the equation, put it in your calculator. Let's finish up the table. 0.88, finish up the table. Our original amount was 50,000. After 1 year, we're going to cut the emissions by 12%. So after 1 year, what do we have now for those CO2 emissions? Smaller than 50,000, right? 44,000. 44,000 after 1 year. After 2 years, it should be 38,720. Then 34,074. And after 4 years, we should cut those emissions back to 29,985. Now that, of course, assuming that every year they cut those emissions by 12%, like they said. Any questions on number 3? All right, I'm going to give you number 4 to try all by yourself here. Now, notice here number 4 says for college fund, Jenny's parents invested $5,000  4 years ago. The account has now reached $6,312. We want to know what is the approximate annual rate, or the R, in this investment. Right now, I just want to see if you can come up with the equation. It's just like we did on Friday. Give me the equation that goes with that table. Give me the equation that goes with that table. All right, I asked you guys to give me the equations. The first thing I need is the A, or ace naught over here, the first number. What is the initial amount that she invested? 5,000. So the very first number you should have is 5,000. Now we're looking for the missing number right here. Well, how are we going to find that missing number? We talked about this on Friday. How can I find it? Well, first of all, let's go back over here to Friday. B. We said B was the ratio. It was the number we were multiplying by. It was the pattern. How did we find that pattern? What did we do? What? Yeah, but what are we multiplying by? And what is it? That's what I'm asking. What is that number? Did you find it? What is it? Good. That is correct. Now, my next question is, how did you find that 1.06? Okay, good. It had to be a number bigger than 1. And how did you know it had to be a number bigger than 1? Good. The y values are increasing, but how did you find specifically that it was 1.06? Why not 1.05? And you just, okay, so you just tried a couple of numbers? Well, do we have to do that? No. You can also just do a ratio or compare these two numbers. Divide 5,300 divided by 5,000. 5,300 divided by 5,000. Guess what that's going to turn out to be? 1.06. So that's how we come up with that number. Now, that's the equation. The question asks for the annual return rate, the R. We want to know, what is the R? Let me give you some previous ones that we looked at. Over here, the rate was 12%. Over here, the rate was 18%. Over here, the rate was 8%. So what I'm looking for is, what is the rate on this one that we just found here? Ah, very good. And where did you find that 6%? What's that? Okay, so that 1.06 is part of it, right? If we ignore the 1 that's in front, if we added 1, and just look at the 0.06, how do you change 0.06 to a percent? You move the decimal over twice, which is giving us the 6%. Very good. All right, let's turn to the next page. Now, those first few that we've looked at were fairly easy, and that's because this interest that we've been talking about has been applied once a year. However, right here, when banks handle investments or loans, they do not simply add that interest once a year. Instead, what they do is give a little interest throughout the year. When a portion of an investment interest is given at an interval throughout the year, this formula is what we're going to use instead. Now notice the difference between the one we've been using and this new one here. Notice there's an extra letter, an extra variable. Do you see it? What's the extra letter variable? N. And what exactly is that N representing? It says right here that N is going to represent the number of times interest is given in a year. Like I said, right now up to this point, interest has been given just once a year. But that's not always the case. Sometimes it's twice. Sometimes it's 3 times. Sometimes it's 4 times. So let's take a look at a couple of those. All right, so here's the scenario number 5. It says we got $6,000 invested at 4% annual interest rate, and we're going to leave it in there for 5 years. So how will this investment change if part of the investment or interest is given ahead of time? So on this first one here, what if we just give interest once a year? Well, in that case, the equation we end up with is right here. Y equals 6,000, because that's how much we invested, times 1 plus 0.04 to the t power. And of course, when we put this in the calculator, this is the table we get. But what if instead of just once a year we apply interest, what if we do this quarterly? Quarterly meaning 4 times a year. So 4 times a year. Put a 4 for N. That's what N is going to represent. 4, because we're doing this 4 times a year. So let's see what the equation is going to look like. Now remember, we're still talking about the same scenario here. We're still talking about investing $6,000. Lorenzo? $6,000 is what we're investing. Inside the parentheses, we're going to do 1 plus R. R representing the rates. What is the rate we're using in this problem? For what? For percent. But how do I write percent as a decimal? 0.04. That's what's going to go right here, 0.04. We're going to divide that 0.04 by N, or the number of times that interest is applied. And in this case, it's applied 4 times a year. That 4 is not only here, but it's also over here. That's what n is. It's the number of times interest is applied within that year. All right, so this is the equation we're working with. Go to y equals, put that in your table, or in your y equals, and let's see what the table looks like. Make sure you type it in exactly like you see it, guys. 6,000, parentheses, 1 plus 0.04 divided by 4, close your parentheses, raised to the 4x power. What's that? 2 for x. What do you mean? Oh, you're going to use an x for the t. What's that? Well, 4 is part of the exponent. It's 4x. So you're using 4x for your exponent. All right, let's make sure we're all getting the same thing in our table. We should see 0, 6,000. What do you see next to 1? 6,000. $243.60. Not quite, but you're close. Everybody go to your calculators and highlight the y value that's sitting right next to 1. Highlight it. Now notice it's 6,243.6 is what you see underneath the y column, but if you look at the very bottom, it gives you even a longer decimal, right? I want you to look at the longer decimal. We're going to round this to the nearest penny. So what would this be to the nearest penny? 62 cents. So we're talking about $6,243.62. What do you see right next to 2? $6,497 and point. No, again, look at. Make sure it's highlighted. Make sure you look at the very bottom of it. 14 cents. Next to 3, you should see $6,760.95. Then we should see $7,035.47, and then $7,321.14. So this is the table of values we're getting. Now notice on this one, I still invested $6,000. I still was looking at an interest rate of 4%. The only difference is we did this quarterly, or 4 times a year. And notice what that did. This first one over here, after 5 years, we're going to get back $7,299.92. But if you look at this one over here after 5 years, look how much I'm getting back this time. $7,321.14. How is that? I put the same amount of money in. It's still at 4% interest. What's the only difference? Yeah, you're doing it. The interest is 4 times a year instead of just once, which is why I'm getting a little more back. Let's try the next one. B, monthly. Monthly. So what is my n going to be if I apply interest monthly? 12. Why 12? Very good, because there's 12 months in a year. So let's see what equation I get this time. Remember, we're still investing $6,000. We're still looking at 4%, so 0.04. The only thing that's going to change is that 4. That 4 is not going to become a 12. So here's the new equation. Go ahead and put that in your calculator and see what you get. We're filling out our table. Make sure we, just like we did on this first one here, A, make sure you highlight the y value so you can see all of the decimals, because we're going to round this to the nearest penny again. All right, teacher, help me out here. What do you see next to 1? And how many cents? 44 cents. All right, what's the next y value? 6,000. No, go ahead. Finish it up.
Start here.
Yes.
Can I have Anna Rodriguez to the front, please?
Okay.
Thank you.
Okay, the next one is 6,485 cents. Next one is $6,763.63. Then we have $7,039.19. And the last one, $7,325.97. So again, notice if you look at the very last one, after 5 years, notice how much I'm getting, $7,325. Again, slightly more than 8. And the reason we're getting a little more is because this time we did it 12 times in a year rather than just 4 times in a year. All right, what I'm going to want you guys to do is try the next two by yourself here. C wants to know what would the account have after 5 years if we're doing this interest every week. And then what if we're doing this every day? If interest is occurred daily. Now think about how many weeks are there in 1 year. Think about how many days are there in 1 year. That's what your N is going to be. Y'all figure how many weeks are in a year? How many? 52. Anybody know how many days are in 1 year? 365. See if that helps you out. All right, Lorenzo, help me out on this first one here. C. We know 52 weeks. There's 52 weeks in 1 year. Remember, we're still investing $6,000. We're still looking at 4% interest. So, here we go, Lorenzo. Y equals what? What's the first number I need?
52.
Look at A and B. A and B, it's the same thing we're doing on C and D. What was the first number? Lorenzo, look at A and B. The equation we had on A and B. They're going to be very similar to what we're going to have for C and D. All right, Gilbert's helping you out. 6,000. All right, Lorenzo, you helped out with the first part. Now what? 1 plus. Right here we're going to put the interest. What are we going to put in? What number? Nope. Oh, you got more help again. 0.04. Now we need the N. What's going to go right here in these next 2 blanks? N. What did we say N was going to be? 52. 52 right here. Now notice, guys, right here they put 5. Why are they putting 5? Well, because we're talking about 5 years. But since we're going to use our calculator, do this for me instead. Instead of 5, let's put x. This way we can put it in y equals and look in our table. So everybody do that for me. Put that in your calculators. Go to y equals and let's type in 6,000 parentheses 1 plus 0.04 divided by 52 raised to the 52x pi. 52 times x. That's your exponent. When you got it in there, go to your table. And in your table, you're going to look right next to 5. What do you see next to 5? $7,327.85. So this is how much we get if we invest $6,000 at 4% interest, and that interest occurs weekly. D, same thing. Still going to have $6,000. That's how much we're investing. It's still at 4%. The only difference here is our N is no longer 52. Now it's 365. And just like we did earlier, instead of using 5 for 5 years, let's use X so we can put it in our Y equals. Let's see what we get. Put that in your calculator. See what you get. $7,000 what? 28 and 33 cents. So $7,328.33 is what we get if we invest $6,000 at 4% interest, and that interest occurs daily. All right, I'm going to stop right there. You guys